Alright, in this lesson we're going to look at some multi-step word problems using our right triangle trig. And in each case you're going to look for the right triangles and draw them out and enter in the knowns, label with a variable the unknowns, and then in most cases you're either going to be adding a couple measurements together or taking their difference. So it usually requires two sets of calculations. And in all these questions we're going to round our final answers to one decimal place. To the 10th place. So let's look at the first one. It says two buildings are 375 feet from each other. So here's my two buildings, and I know that their distance between them is 375. Going from the inside dimension there. So from there, over there, that's 375. And let's see, the taller building has a flagpole, and then someone down here is measuring the angle of elevation from the ground up to the top of the building, and then from the ground up to the top of the flagpole. So we have two different angle measurements. So the smaller angle measurement is 46. That's this one here. So I'll put a 46 here. And the larger measurement is 53 degrees. That's the other one. And we want to find out how tall the flagpole is. Well, to do problems like this, we have to see that there are two right triangles. So we have one of the right triangles that goes up to the top of the flagpole, and that has an inside angle of 53 degrees. So there's my 53. And then the other one is the smaller triangle that has the angle of 46 degrees. So I'll put him down here. That's 46 degrees. Now they both have the horizontal distance in common, so 375 is going to go here and here. And in both cases we're trying to find the height. So I'm going to label one of them X and one of them Y. So the height up to the top of the pole will be here, and the height up to the top of the building will be here. So this is going to be X, and this is going to be Y. So if I have the difference, or the height of the two things, to find the height of the flagpole, it's just going to be taking the difference of the two. So we're going to find X minus Y. So from here, if you look at what you really have just two simple right triangle problems. Opposite over adjacent means I'm going to use the tangent. So the tangent of 53 is equal to X over 375. The tangent of 53 is 1.327, so 1.327 over 1 is equal to X over 375, and you get X is going to be approximately 497.64. Okay, now we do the same thing for the top of the building. Now we have the tangent of 46 degrees is going to be equal to Y over 375. So the tangent of 46 degrees is 1.0355 over 1. That's equal to Y over 375. You cross multiply, and your Y value ends up being 388.32. So I know that all the way up to the top of the flagpole is going to be 497 and some change, and the height of the building is 388 and some change. So to get your final answer, you're trying to find X minus Y, and that's 497.64 minus 388.32, and let's see what that gets us. And you end up with 109.3. So 109.3 feet. So what we did in that problem was break it down into two separate triangles and then take the difference of the two. So in our last example we subtracted. In this example, if you take a look, I have a single point and I have an angle of depression measuring from this point down the angle from that point down to the bottom of the water tower, and then an angle of elevation from the same horizontal line up to the top. And I want to find the total height of the water tower. So what I'm going to do here is break this up into two triangles, and I'm going to add the distances. So if this is x and this is y, I know my final answer is going to be x plus y. The horizontal distance is 325 in both cases. So if I look at that, here's my lower part. This is 25. This is 325. I'm going to use the tangent again. The tangent of 25 is going to be x over 325. So the tangent of 25 is 0.4663. 0.4663 over 1 is equal to x over 325. And in that case, you're going to get x is 151.55. That's the bottom half. And now we got to go find the top half. Here's the y and 325, and this is now 39 degrees. So again, we're going to say the tangent of 39 is equal to y over 325. The tangent of 39 is 0.8098. So you set up your proportion and you solve for y, and this time y is going to be 263.18. Now you're going to add them together. 151.55 plus 263.18. If you add those two together, you end up with, let's see, 414.73. So rounded to 1/10, it's 414.7 feet. Again, we broke this problem up into two right triangles, and we just added the final answers together. All right, now this one is a little bit more algebraically challenging based on if we're going to solve it with right triangles. There is another way to solve it, which you'll figure out next year using something called law of sines. But this year we're going to try to get away with just right triangle trig. So here we have a mountain, and we want to know what the height is. I'm not given an awful lot of information. I'm not given this distance here. I'm only given the little distance here. And I have two angles of elevation to the top. But I can still use that, because if I think of my entire triangle or side length here, this is going to be x plus 0.5. But I still have h I got to deal with. So let's look at this. So I have h and 34 degrees and x plus 0.5. And then my second triangle is h and 40 degrees. I should have made it taller. And this is x. So we would still use a tangent function. Tangent of 34 is equal to h over x plus 0.5, and let's just go ahead and solve for h. So tangent of 34 is going to be 0.6745 over 1, and that's equal to h over x plus 0.5. Well, if I'm going to cross multiply, I'm going to end up with an expression for h, and that's going to be equal to, remember this is a binomial, 0.6745x plus 0.3373. Okay, that's the first triangle. And the second triangle, it's a little bit better, because we have the tangent of 40 is equal to h over x. The tangent of 40 is 0.8391, and that's equal to h over x. So here I have another expression for h. This time it's only 0.8391x. Well, I have two things that are equal to h. So when two things are equal to the same thing, they are equal to each other. So what I got to do is I got to find a value for x so I can go back in and replace it and find a value for h. I can do that because I'm going to set these two things equal to each other, and I have 0.6745x plus 0.3373, and I've got to find more room here. Let me do this again. 0.6745x plus 0.3373 is going to be equal to 0.8391x. That's a first degree equation. I subtract this. You treat it just like a first degree equation. Just because your coefficients are a little goofy, it doesn't matter, because in the end it's going to work out. And this is equal to 0.8391 minus 0.6745, 0.1646x, and then you divide, and you get x is approximately or is equal to 2.049. Now you take this answer and replace x in there, replace the x in there with it, and you find your value of h. So the numbers are goofy, they're not whole numbers, but that shouldn't matter. The process is the same. And finally, h is going to be 1.72 rounded to a tenth is going to be 1.7 kilometers. So this problem you should probably watch again so you can kind of understand what I did. I had h and x only, and I had to set up two equations, solve both of them for h, and then I set them equal to each other. And that's how I got a value for x, which in turn gave me a value for h in the end. Alright, one more for your notes, and then we're going to practice this stuff in class. A person is flying a kite, and the kite is 290 feet high, which means it's above the ground by 290 feet, 95 feet. So that's 295. But this person is a certain amount of feet above the ground, and the angle is 56 degrees, and there's 350 taut feet of string for the kite. So I want to know how tall the person is, or how high is the person holding the kite from the ground. Well, in this case, we're going to find this value and subtract it from 295. So if I look at this, this is my y. I need to find y, which is not tangent this time. Now that I need opposite and I have hypotenuse, I need to use the sine function. So the sine of 56 is equal to y over 350. And the sine of 56 is 0.8290. And we set up our proportion, and y ends up being 290.16. So we're going to say 290.2 since our final answer needs to be rounded to a tenth. So the height, x, is going to be 295 minus 290.2. And we end up with 4.8 feet. That doesn't mean 4 feet 8 inches. 0.8 times 12. It's actually 4 feet and about 9.5 inches or so, 9.6 inches. So it's probably a kid then. It's not like an adult, or it's a very short adult. I don't know. Anyway, those are 4 examples of multi-step trig problems using right triangle trig, and we're going to practice a lot more of this in class.